Okay, so the first thing, if you if you just started out drawing a free body diagram of the beam, how many unknown reactions do you have over here at the wall? You you have three. You have the force vector and the couple, and then you in your free body diagram of the beam, you have another unknown here, the tension of that cable. So we know we need to figure out the tension of the cable. So I'm going to start by, isolating the 200 kilogram mass and just calculate the tension. Uh, in statics, one thing that I don't like about doing these kind of problems in statics is you can get a little bit lazy with this kind of stuff, and you can get kind of bad habits, I think. Because in statics, you can just look at this. The weight of this is 1962 newtons. Um, and so that's the tension in the cable, and that's the end of it. That wouldn't be true if this was dynamics. And so I think the fact that you can take sort of those shortcuts is kind of leads you down a bad path. So, anyways, I'm gonna draw it out. So a free body diagram of the mass, the 200 kilogram mass. We have 1962 down. We have the tension up. And so Newton's second law says 0t plus 0 negative 1962 is equal to zeros. If you look at this equation, you can see why it wouldn't be that simple if this was moving, if this was dynamics. You'd have some acceleration and tension would be different from the weight by that amount, by the mass times that acceleration. In statics, though, it is that simple. T is just equal to 1962. And now we can go on to the free body diagram of the mass. What did I say it was? 500? Okay, so we have a force that way of 1962. We have a downward force of 4905. And we have an unknown force vector. I'll call that R, and then a couple, I'll call that MR, like the reaction moment. Now I'm going to set up the table. Okay, so to simplify the math a little bit, the best place for the about point is at that fixed joint. I'm also going to put the origin there, but remember, you don't have to put the origin and about point in the same spot. I end up doing that pretty often. So first, that force R is at the origin. The about point is at the origin, so there's no row vector. The force is Rx, Ry, and there's no moment. Then there's the reaction couple, Mr. None of the other categories matter for that couple. And now let's do this point. Well, the geometry here, this is a right triangle. This is 40 degrees. And so this hypotenuse is 2.5. So we're going to have negative 2.5 times the cosine of 40, negative 2.5 times the sine of 40. You could also, think of it as you're going all the way around. You're going well, this angle is the same as this one. So you're going 180 plus another 40. So you could use 2.5 times cosine and sine of 220. So what do you get for these points? Okay, one. And both negative. The about point is the origin. That force vector is, let's see. Yeah, right, 220 minus 90, or if you go from here, you could think of it as 40 plus another 90. So cosine and sine of 130 times 1962. So what do you get for that? So this is 1962 times cosine of 130, 1962 times the sine of 130. We'll figure that out when we go to Newton's second law. And what about the moment? Well, you could do that sort of ugly cross product, or you could just notice that this is a force of 1962 going this way with a moment arm of 2.5. Either way is fine, you know, like you could calculate that cross product and your calculator does it easily. Or you could just recognize it's going to be a moment producing a clockwise rotation about the about point with a magnitude of 1962 times 2.5. So what's 1962 times 2.5? Oh, 4905. And it would produce a clockwise rotation, so that's going to be negative. And so now we have Newton's second law from these, the rotational equation from these. So Newton's second law says Rx, Ry plus, can someone calculate 1962 times cosine of 130? And okay, and then the y? Okay. Ah! Yes. So the location is going to be the average of the origin and negative 0.96 and negative 0.80 or 81. So the row vector is negative 0.96, negative 0.8. The force vector is 0, negative 4905. And so the cross product is 0.96 times 4905. What does that give? 4696. Okay. Okay. 4708. Okay, so this plus 0, negative 4905 is equal to zeros. And so the reaction force is equal to positive 1261.2, and then negative, no. What do you get when you add these two together? Okay. Yeah, that's the right ballpark, yeah. Okay, and then the rotational equation says MR minus 4905 plus 4708 is equal to 0. What? Yeah. I think that seems right, doesn't it? So MR is equal to negative 197. So you get a positive if you, oh, 49. Yeah, sorry. You're right. So add those together and you get negative, and then move it to the other side and you get positive 197. And these are in newtons. Any questions about that one? Okay, so you should be ready to go on all the, you can work on all the practice problems for the rigid body stuff, the free body diagram problems and the statics problems. And then next time we'll start talking about centroids.